Hey everyone! So, what if I told you the next huge leap for AI has nothing to do with just making our computers faster? Like, not at all. Today we're diving into something truly mind-bending, a whole new frontier where we're combining artificial intelligence with quantum computing. It's wild stuff.
So let's just start with this big question. What if the next leap in AI isn't about faster chips, but about unlocking a totally new dimension of computation? What if it's not about running faster, but about, well, thinking differently? That's the core idea we're going to unpack right now.
All right, section one, the next leap for AI. We're talking about a new synergy here for solving what are, right now, completely impossible problems. I mean, think about it. This isn't just a simple upgrade. It's like we're being handed a whole new playbook to solve problems that even our biggest, baddest supercomputers just can't touch.
So, at its core, the idea is actually pretty straightforward. You take what AI is amazing at, right? Finding patterns, learning from data, and you pair that with the truly weird and powerful physics of quantum computing. When you put them together, you can explore these gigantic solution spaces that classical machines they can't even begin to handle. It's a fundamentally different way of problem solving.
Okay, so before we go any further, we got to do a quick Quantum 101. A little crash course. But don't worry, I'm not going to throw a bunch of equations at you. We're just going to cover the absolute basics, the building blocks you need to understand to see why this is such a big deal.
All right, it all starts with this thing called a qubit. Now, you know how a normal computer bit is super simple. It's either a 0 or a 1. That's it. A qubit, though, it's different. It can be in what's called a superposition, which is a fancy way of saying it's kind of both 0 and 1 at the exact same time. And that ability to hold way more information, that's where the magic starts.
And then there's the next piece of the puzzle, which is even weirder, entanglement. Einstein himself called it spooky action at a distance, which is just an awesome name. Basically, you can link two qubits together, and their fates become connected. No matter how far apart they are, across the room or across the galaxy, if you measure one, you instantly know the state of the other. It's this incredible spooky connection that gives quantum computers another huge advantage.
I love this analogy. It just makes so much sense. Think of our classical computers, our laptops and servers, as these amazing marathon runners. They are incredibly fast, super reliable, just grinding through problems one step at a time. But a quantum computer, it's more like a rock climber. It's not trying to run the same long, winding path. For certain, very specific, very hard problems, it can see a vertical shortcut and just go straight up, a path the marathon runner couldn't even dream of taking. Okay, but here's the thing about that rock climber. Right now, today, it's not quite ready to climb the whole mountain by itself. It's powerful, but it needs a guide. It needs a classical partner. And this is exactly where AI comes back into the picture, in what we call the hybrid AI approach.
See, right now we're living in what experts call the NISQ era. NISQ. It stands for Noisy Intermediate Scale Quantum. And what that really means is that today's quantum devices are powerful, yeah, but they're also kind of small and, well, fragile. They're super error-prone. The tiniest vibration, a slight change in temperature, can mess up the whole calculation. That's the noisy part, so they really need help.
And this is how that help actually works. It's this awesome hybrid loop. So, step 1, a regular classical computer sets up the problem. Then, step 2, it sends the absolute hardest part of that problem, the rock climbing bit, over to the quantum processor. Step 3, the classical computer reads the answer that the quantum machine spits out. And now for the most important part, step 4, an AI looks at that result, analyzes it, and then intelligently decides what to try next. The AI is basically the smart coach, guiding the quantum rock climber, saying, okay, that was a good attempt, now try this route.
Okay, so we've talked about the how. Now let's get to the really exciting stuff, the what. What are the frontiers this can unlock? What are the massive, maybe even world-changing problems that a quantum AI could finally help us solve?
And the potential applications are just huge, but they really boil down to a few key areas. We're talking about cracking incredibly complex optimization problems, things that are just impossible now, simulating molecules with perfect accuracy to discover new drugs, even creating entirely new kinds of machine learning, and on the flip side, next-generation cybersecurity.
Let's dive into optimization and logistics for a second. Think about a problem like trying to find the absolute most efficient route for a global supply chain, or balancing a nation's energy grid in real time. The number of possible combinations is it's astronomical. A quantum AI hybrid could sift through that massive space of possibilities to find the one best answer. It's a scale of problem we just can't handle right now.
Or what about simulation for discovery?
I mean, this is a huge one. Nature itself operates on quantum rules. So if you want to perfectly simulate a new molecule for a drug or figure out the chemistry for a much better battery, you kind of need a quantum computer to do it. Imagine designing life-saving medicines or new materials to fight climate change, all inside a computer, before you even run a single physical experiment. That's the prize here.
But, okay, let's take a breath. Time for a quick reality check. Getting to what's called quantum advantage, that's the point where a quantum system truly undeniably beats our best classical computers on a real-world problem. That is a very high bar to clear. It's not going to be for everything, it's problem-dependent, and the quantum solution has to be better from start to finish, not just on one little piece.
So, keeping all that in mind, how do you actually prepare for this quantum future? What can you do right now? Well, this last section is your quantum playbook. We're going to lay out some concrete steps for how to get ready. This table really lays it all out perfectly. On one hand, you've got classical AI. It's mature, it's production ready, it's reliable. It's the go-to for most of what we do in machine learning today. On the other hand, you have the quantum AI hybrid. It's still early days, it's targeted, it's experimental. Its strengths are in potential speedups for very specific, hard problems like optimization or chemistry. There are different tools in the toolbox for sure.
Okay, so for all you builders and data scientists out there, here's your playbook. First, start learning these hybrid workflows, things like variational circuits and classical optimizers. Get your hands dirty with some of the quantum machine learning libraries and simulators that are out there. But, and this is so important, always benchmark what you're doing against the best classical approaches. That's the only way you'll know if you've actually found a real advantage.
And for the leaders and teams listening, your playbook is a bit more strategic. Start by creating a quantum watch list. What are the high-value problems in your business that this could completely change? Then start building talent bridges. Get your machine learning engineers talking with quantum experts. And this is a big one. Start planning for post-quantum cryptography, or PQC. You need to be thinking now about how to protect your data from future quantum attacks. So if there's one thing to take away from all this, it's this crucial point. Quantum AI is not a replacement for your current AI systems. Not at all. You should treat it as a strategic R&D track. It's a long-term bet that could pay off with absolutely massive breakthroughs, but only for a very specific class of problems. And that brings us to the end, and I want to leave you with this one last question to think about. If you had access to a tool like this, one that could find these incredible shortcuts to unsolvable problems, what would you tackle first? What's that big, hairy, impossible problem in your world that you'd finally have a shot at solving?